Hi everyone, welcome back. Today we are going to see the pressure sensor in HVAC system. So, in a building automation system, it is called as BIS, which is involving the monitoring and adjusting of heating, ventilation, and air conditioning. It is nothing but HVAC. And how the HVAC system it affect, it changes, it react the changes in air pressure in the environment in a building automation system. Okay, so in modern HVAC system, it may use an air intake, exhaust fan, relief damper, and other some of the pressurized equipment in a building. Okay, so in pressure sensor in HVAC application, that is heating, welding, and air conditioning system used, and pressure sensor is a device which is used to measure the pressure in various fluid or gases within a system of HVAC. So the pressure sensor it plays a very crucial role in maintaining the efficiency of a system and safety of a system and proper functioning of an HVAC system. So this temperature and pressure measurement is very important in an HVAC applications. So these are the few types of pressure sensor which are used in the HVAC application. The first one, differential pressure sensor. Differential pressure sensor. So here you can see. Here a boiler is there. So here some of the fluid, water or some of the fluid is there. So with the help of furnace, the water gets boiling. So here we are measuring the heat in the fluid as well as in a vacuum. So we are comparing the two pressure. One is from the boiling water, another one is the vacuum in the boiler. The two pressure will be compared. So it is nothing but a differential transducer. And another example. So this is a duct. So duct, or it may be a pipeline. So in this pipeline, here I am supplying the water with a pressure of 34 psi, pounds per square inches. It is a unit of air pressure or water pressure. Okay, I am supplying the water. But so in between the pipe, I am keeping the filter. So the filter which is used to eliminate the particles, unwanted particles, dust. So if the filter circuit, once the filter is accumulated by the dust, here the flow of pressure gets dropped. So that here the 34 psi is changed as 24 psi. So because and filter it is full of dust, so it doesn't allow the water with same velocity, same pressure. So that it is restricting the flow of water. So that the pressure gets dropped. So with the help of this differential pressure sensor, we can able to measure the pressure before the air filter and after the filter. That is before the filter and after the filter. So while comparing, before the filter is 34 psi and after the filter is 24 psi. Okay. So the difference is 10 psi. Suppose if the difference is low, the filter is working perfectly. Suppose if the difference is increases, it denotes the filter is having certain amount of dust accumulated. So we have to clean the filter. And if the pressure is again increases, the pressure differences again increases, it denotes we have to replace the filters. And next one, absolute pressure sensor. So an absolute pressure sensor, here we are taking the reference values vacuum. And with respect to vacuum, we are measuring the pressure. Here an example, if you want to measure the pressure less than atmospheric pressure, the absolute pressure sensor is very essential. Like in a refrigerator, is a closed system. Here the pressure is less than atmospheric pressure, so that we can measure the pressure with the help of an absolute pressure sensor. And next one, cage pressure sensor. In cage pressure sensor, we are taking the reference value as atmospheric pressure. If the atmospheric pressure is 14.7 psi, pounds per square inches, the measured values above the atmospheric pressure, it indicates as positive pressure value. If the measured pressure is less than 14.7 psi, it indicates negative. It indicates as negative. It is below the atmospheric pressure. So we are keeping the atmospheric pressure as a constant in order to measure the value. And the applications are to measure the duct pressure, to measure the pressure in the duct, and to monitor the filter how it is working healthy, and to work on for the ventilation control, fan control, and to measure the temperature in the boilers and furnace, and also in refrigerant pressure. If the pressure changes is within a permissible level, nothing is happened. If we can identify whether the fault is occurred, it may give an alarm to the operator. If the difference is too high, it is a very emergency, it will be immediately prevent the operation, immediately shut down the system in order to avoid the damages. Okay, so that the system which is used to save the energy efficiency, and here we can able to operate it remotely with the help of IoT applications. And this is an assessment. Can you guess this is an example of which method of heating, ventilation and air conditioning? Okay, and these are the reference for this